The pump for my well makes me spend up to 300 euros more on electricity every year. Why is that? Because it was sized incorrectly. In this video, we'll see how to size a pump. So we'll understand what flow rate is, what pressure is, but most importantly, we'll see which pump I'm going to install. Exactly to achieve this significant savings every year. 3 years ago, when I made the well, I didn't worry too much about what I was installing in the well. So, the pump that was going to be installed. In fact, the only parameter I set for myself in a makeshift way was the power that this pump needed to have, 1.5 horsepower. However, in the past year, I've done several projects with Franklin Electric, and I realized that my well has two issues, or rather my pump has two issues. The first one is the power consumption. My pump is traditional, so it works on an on-off basis, meaning it's either off or running at full power. Even when I only need a little water, you understand that the bill gets pretty high. And the second issue, which isn't visible, is wear and tear. In fact, the more I always run the pump at full power, the more naturally I'll have much more wear. So the pump lasts much less. So the decision I made was to redo the whole system, which was really done in a very homemade way. And to install a new pump with a very, very special technology. I will install a high-efficiency pump with a permanent magnet inverter motor, and this will solve the two problems I mentioned earlier. So I will lower the bill by up to 20% with much lower consumption. And above all, the pump will not always run at maximum speed, but rather according to the demand from the system.
Unlike traditional motors, the permanent magnet motor has a different rotor composition. This means that the motor operates at a lower temperature, so it has less friction and, as a result, greater energy savings.
What are we going to do? We are going to redo the entire hydraulic system done by a professional. This is what I did in a very, very amateur way, and we are going to replace the installed pump, also installing an inverter.
The permanent magnet motor requires the use of an inverter. We have developed an advanced inverter that allows us to manage the system, monitor data in real time, and above all, we offer the possibility of remote assistance.
So, in this and the next video, you will see all the work that has been done. What is the goal? It's to give you a clear idea of what you need and what a job done properly looks like, so that you also know what steps are necessary to install both a correctly sized pump and a new technology pump. But above all, you'll have an idea of what it means to redo the entire system properly. Now, to properly size the pump and avoid repeating the mistake I made a few years ago, we need two pieces of information: the flow rate and the pressure. This is something I should have done, or rather, maybe the person who made the well for me should have done it. So, I'll show you how to find both the pressure and the flow rate of your well, but not before explaining to you what both flow rate and pressure are. Otherwise, we won't know what we're discussing.
The flow rate is the amount of water we can extract from a well in a certain amount of time. Here, we're referring to liters per minute, liters per second, or cubic meters per hour. Pressure is the force with which we are able to extract the water and push it into our system. In the case of pumps, we talk about pressure and head, which is the height in meters to which the extracted water can be pushed. To understand what the right pressure is, and therefore the head of our pump, we need to know the installation depth and the levels of the well. And secondly, what the configuration of the system is. We need these two pieces of information to correctly choose the most suitable pump so that it is neither oversized nor undersized. In the first case, we would face extremely high operating costs that would be wasted. In the second case, if the pump is too small, we can't ensure the proper use of the system or its correct operation.
A quick disclaimer: this video aims to help you understand each individual step clearly. So for sure, if an engineer or a plumber watches this, they'll notice some small imperfections. My goal is for you to understand as clearly as possible what we're talking about. So sometimes I might use terms that aren't exactly perfect. Because the goal is for you to be fully aware of exactly what you have installed, what you need, and when you talk to a plumber or an installer, you also understand what we're talking about. They're now installing a whole set of instruments to figure out what the well's flow rate is. Now we'll let them work. But you see, installing takes just a few minutes. Everything is set up. I'll show you how the first test is measured. As you can see, sensors have been installed. They are ultrasonic sensors. We're measuring the pump's flow rate at peak demand, so be careful because there will be several stops for different measurements. Here we have 6.1 cubic meters, which is about 100 liters per minute. This is the system's flow test, which is the maximum demand I'm placing on it. Now let's go check the maximum flow rate of the pump. Right now we're doing an open-end test. This hose is connected directly to the pump. We've disconnected it from the system to see the maximum flow rate the pump can deliver. So these are two different measurements. In fact, you can see the numbers have changed. They've gone up, so we have about 7.5 cubic meters. Now, when we go to measure the flow rate, we also need to figure out what the dynamic level of our well is. What does that mean? Static level means where the water is, basically. In my case, we have it at about 10 meters. Dynamic level is when I turn on the pump, how much this level can shift. In my case, I don't do this measurement. Why? Because in the last 3 years, I've always had the necessary flow rate to make the system work properly. So I'd be collecting data I don't need right now to size the pump properly. Now we've installed this little sensor here because throughout the week we'll be checking how much the pump that's currently installed consumes. That way, when I show you the consumption of the new pump, which will be installed with permanent magnets and an inverter, we'll have scientific data and you'll also be able to see the difference empirically. Now, a few days have passed and over there is Marco, who has done all the calculations and sizing. Now I'll go get him, otherwise I'll disturb them. And let's go see which is the right motor.
We've received the data. Now, can we select together which solution or solutions fit your case best? We can go to the Franklin Electric website where we find our selector, which is a software we developed to make customers independent in their selections, where you just need to enter the flow rate and pressure that we found and that we need to choose the correct pump or the most suitable solutions for our system. If, on the other hand, the selection is more complicated, we are still available to assist you and help you in choosing the product. So, Matt, this is the pump we're proposing to you, and if you agree, we'll have it prepared, sent to the installer, and then we'll get in touch again for the initial startup.
As you saw, I just left and they sized my pump perfectly. So what did we learn today? We learned that, first of all, it's important to know the flow rate of your well, and that's information you'll need for everything else later on. And the second thing is that it's important to size your pump properly. This will definitely reduce wear, but most importantly, it will give you greater energy savings. Now, we'll see each other in the field in about a week because they're already making the pump for me. The plumber will come, and then with the plumber, we'll go install everything. And I'll show you how we'll set it up, because even there, we'll need to set the pump to make it work efficiently. We'll make it work within the best range to get the best performance and always keep energy consumption as low as possible. So I hope you enjoyed this video. The comments are down below. I know there will be a lot of questions, so write them down below and we'll try to answer them. I'll see you in the next video. Hello everyone.